for joining us for the last session of this 5 days FDP. But we have a little housekeeping before we get started. Vivek sir has to make few announcements. Vivek sir?
Yes, ma'am. All participants are requested to kindly fill the feedback form by logging into the portal of AICTE. That is AICTE ATAL Academy portal, where you have already done your registration part. So, because as per AICTE guideline, to issue the participation certificate, you must have 80% attendance, minimum 60% score in the test, which will be conducted at 2 p.m. today. And you must have filled the feedback form through the AICTE portal only. Okay. So, yes, ma'am, you can continue.
Okay, then continue. The session titled Development of ONGC, and all of us are really blessed. Mr. Prakash Mahawar has a 36 years of vast experience with this public sector undertaking ONGC. He is a former director onshore of ONGC and OMPL, and also our 1980 batch alumni of mechanical engineering. As I mentioned at the beginning, he possesses more than 36 years of long and extensive experience of managing drilling and operational functions while holding various key positions across vast spectrum of oil field utilities. As a mechanical engineer graduate, he started his career with ONGC as a drilling engineer in the year 1982. He is also known as first sub-sea engineer of ONGC. He has, to his credit, more than 25 papers presented in international conferences. He also developed well-controlled manual for offshore operation and also brought an fully accredited international well control school for the first time in India. With his dynamic, bold, and decision-making and visionary approach, he was selected as director onshore of ONGC in the year 2015. In his 3 years of tenure as director, he brought many remarkable changes, from revising the decline trend of crude oil production to creation of new assets, improvement in reduction of gas flaring, and many more. He was conferred with Center for Excellence in Project Fellowship Award 2016 for his outstanding contribution in the area of project and risk management, and also received Lifetime Achievement Award by Green Tech Foundation. Presently, he is working as a Board of Governor, acting chairman of IIM Rohtak, and also he is also president of the Society of Health, Environment, Safety and Sustainability Professional, New Delhi. After retirement from service, he is helping at large and helping industry people. His social work regarding CSR towards women empowerment is worth mentioning. He has also adopted a tribal village and also promoted national language Hindi in Northeast. Recently, in August 2020, he played a key role in capping a blowout well in Baghyan field of Wild India, Assam. Sir, we are truly honored to have you here with us for this session, and we extend a warm welcome to you and request you to kindly start the session.
Thank you very much. सबसे पहले मेरे साथ गुरु को नमस्कार. Thank you for a good introduction. I think you got a lot of things about me. I don't know from where. When I asked from where you get this, so Google has picture. So I'm visible clearly.
Yes, sir, you are quite visible.
You please centralize in your sitting. Actually, part of you is visible, sir.
Part of me?
Yeah. Some part is hiding actually. So you be centralized on the camera actually.
मैं तो सेंटर में
now it's all right.
It's okay now.
अच्छा. मैंने अपनी कुर्सी खसका लिया अभी. Actually, I was
very nice to have you, sir.
तो ऐसी है जब हमने वेल कंट्रोल स्टार्ट किया था इंडिया में, तो वो जो गुरुजी बनते प्रिंसिपल को टेस्ट देना होता था. I used to sit in that test, and there was 3 papers and 90% in each you have to score. So not score less than 90% in any of them, then you are failed. So 3 times I have scored all 100 in all 3. But credit goes to my college in Bilaspur. It was all because that I could do it. My teachers and mentors. So friends, according to all of you, first of all, thank you very much for giving me this opportunity and to interact with you all. Uh, my presentation, I've not written much thing because I don't know, enjoy writing things. I enjoy discussion on these in this kind of forum. So my presentation basically E&P sectors in oil and gas, what kind of infrastructures are there. So what I do is first I'll explain because this is a very new field. When you talk about oil well, when you think come into the mind that well is there, तो ऐसा लगता है कि पता नहीं पानी का कुआं है किस तरह का कुआं है. But it's totally different thing. And thanks to my college that I do in the ONGC because of the nurturing and because of the education which was providing to this college, government college. तो मैं पूरा क्रेडिट वही देता हूँ. मैं जो भी करता था मुझे कॉलेज का पूरा ध्यान आता था कि हमारे गुरु जैसे पढ़ाया. मैं चाहूँगा कि आप लोग भी आई थिंक टीचर्स आर हियर inculcate that kind of things because this is the thing. Value system definitely work and definitely will carry on to the people. मैंने एक चीज सीखी थी कि बेसिक्स पे हमें बहुत ध्यान दिया जाता था हमारे यहाँ. तो उस बेसिक्स की वजह से मैं काफी चीजें कर पाया क्योंकि बेसिक्स जब आपके क्लिक हो जाते हैं तो आप चीजें कर पाते हैं. So in this, I will tell you what are total E&P oil and gas का level है. उसका पूरा गेम क्या है, इस तरह से वेल को डिल करते हैं और किस प्रोडक्शन आता है. So from scratch to production, I'll tell you the process and what are the infrastructures needed for that and how we can help in improving those infrastructures. That will be my focus on this. So I will share my presentation and not speak much because there are बहुत बोल गया है. So let me see if I can share my presentation. The presentation is visible now.
Yes, sir, your presentation is visible.
Okay. So let me put in a full screen. Okay. So I'm going to talk about how the oil and gas is extracted. What are the different activities which are there? So let us understand that those activities, and after those, once we understand those activities, we will be talking about the infrastructures which are needed and what kind of things are used in oil and gas industry. This is totally different because when I went there and I found it very challenging because it was mentioned that I was a first subsea engineer. So everything under the sea is happening. So how the things are happening, initially we were thinking that how we'll understand there are 200 lines going down below and how we'll understand which one is leaking. So again, thanks to my college because they have taught by a book, I think hydraulic one block, not by Khurmi. So I could do it because of that. So क्योंकि बेसिक्स का क्लियर कर दिए गए थे. So when we start any operation in oil and gas, once the block is given to you by Government of India, nowadays bidding is there. Once you win the block, and the first thing which is being done is a seismic survey. If you see here, the survey is being shown. So with this seismic survey, I'll explain what are these operations and what are the infrastructure needed for that. So with this seismic survey, we will come to know that where the oil and gas is, or the quantity will not be known, but how this is being done, I'll explain in the next slide. And once the seismic survey is done and the data are collected, their interpretation is being done. And based on the interpretation, it has been told that these are the areas where we can get oil and gas. If you see the slide number 1 here, in the figure number 1 here, it is shown that rays are coming, sound waves are coming, and these waves are being collected here, and they are being then processed later on the land. Once that is being done, then a location is released. Okay, here, these are the coordinates where you have to drill the well. So once that location is released, then the person will go and survey that where this location is, whether we'll be able to approach there, whether we'll be able to drill there, or we need to change the location and all these things, or we have to use some technology to drill at that particular point of that particular point. So for that, the land survey is being done, but if it is offshore, then absolutely there's no issue. But in offshore, only thing we have to take care that no military activities there and no pipelines, because nowadays subsea pipelines are there. So these are the things which should not be there. And once this is being done, the land is being acquired, and for that there's a team available everywhere. And once the land is there, then we prepare the drill site. Here, a lot of engineering, a lot of structural engineering is required. So I'll discuss this in detail. So once the site is prepared, if you see this number 2 slide, see the one side is prepared on the hillock side. If you see that that hill portion is being cut, and then this the all installation has been done here. Then once the site is ready, then this movement of the rig start. A lot of equipments are available there. You see, I'll explain that also. Once these equipments go there, then the well is being drilled. And these wells are being drilled to the depth of 1000 meter to 5500 meters. So in Assam, when I was there, I drilled deepest well was 5500 meters. So these kind of now you can understand what kind of infrastructures and machines are needed to go down below the earth about 5.5 kilometers. So once the well is being drilled, then the well is being tested. So with the testing, we come to know that what kind of reservoirs we have encountered, whether we'll be able to produce economically, or we can leave it for some other time when we get the new technologies available, we'll be able to produce. So this kind of things are there. And then we take the production. Once we see that economically it is viable, then we go for a production from that well. Once the production is there, because the Mother Earth has got a lot of things, it has got oil, gas, some water, some minerals, things will be going along with the oil. So when this comes to the surface, then oil, gas, water, everything is being segregated. So there again, the infrastructure is needed for that. A lot of design work is required. And then once the oil is being separated, gas is being separated, and the pure form of the gas goes to the plants, and the oil goes to the refinery. So this is the way the things are being done in this. If you see the well is visible here, there's another well. So I'll discuss in detail about all this. I'll seismic survey how it is being done and what kind of infrastructures are needed. If you see the figure, this first figure, you are seeing a one truck, vibrator truck is there. It creates vibration here, and the sound waves travels, some reflects, and then comes back to the surface. And there are a lot of recording geophones are there. These geophones are recording those refracted and reflected sound waves, and they are being recorded. So these vibrator things are done basically in the desert. When you see the desert, these heavy equipments are used. So what kind of things are needed? You can imagine that. Another figure, if you see here, wherever the deserts or plain land is not available, hillock and other places like this kind of place is in a jungle. So how to reach there first? So you again you have to make the roads and all these things, and woods also to make the kind of wood which is there, which is there. And then here the shallow wells are being drilled. Wells of 10 meters are being drilled, and then the electricity is placed, and that is blasted. So that creates the sound, and that sound wave travels down and comes back to you. This is another way of doing it. One is a vibrator, and another is word that exposes sounds. That sound It's another way. So again, now the friends can understand that here I have measured these I have such and the uh, in offshore comparatively it is that kind of discussions are not there. But process is same. Here the this and those you see the weight standing here. This is location I can say, but you see the other side is the hip of the so again here equipments. This is break. This got a lot of structure here. This structure is designed. And this design of the structure because when I was I and roads are to be traveled up and down. So again, you'll see the things for that. Where this stands, if I talk about civil point of view, the foundation which are to be made, I think those foundations are very, very important. How we have to make those foundations for the particular load. That again the engineering part there. But these some again good again design. We will not be able to take the load kind of it's about 3,000 tons of tons when the well. So and because of the sea forces worldwide, nobody is designing these jack-up bricks because these, if you see these legs, it is a leg. These legs push down to the ocean floor and it creates in the sand, sea bottom, and then this complete is jack. The complete rig is jack. I'll show you one figure how this thing. So these rigs can be a barge or can be self. That design can be done based on. Another thing is a drill ship. This is a drill ship. It's a boats on the bottom. Again, the design of these depends on what kind of depth you are going to use it and what kind of loads you are going to handle on this. Because this is all so this kind of that is done by these vessels. The weight of that should be at equal to or more than weight of the ship and variable load. Because this displacement of water, if you see here, is very, very important for this variable load. fixed load, we know the equipment and all this. This variable load makes a lot of difference. If this variable load requirement is not met, in some of the cases we have seen that GM, center of gravity and meta center, when we lower a particular heights in it, it becomes negative, which is very dangerous for this kind of brakes. So that kind of design are to be taken into consideration when we are designing a drill ship. If you see here, it is a semi-submersible. It has got twin hulls basically. One hull which is not visible right now. It is submerged in the water, and if you see the area of the contact is reduced here. So in this kind of rig, the stability is very good. These rigs are more stable. In the deeper depth, these kind of rigs are being used. But this is also used. This is also used. But only thing is because the area of contact is more here, and that is the reason the stability of these drill ships are not better than the semi-submersible. So the semi-submersible rigs are being used nowadays up to 3,000 meters depth. The deepest well which we drilled in the water is 3,047 meter in India, and we use the semi-submersible rig there, and that is, I think, at present about 2,400, 2,500 meters wells are being produced, but in the deeper depth, till now we are searching for the technologies. Developments are taking place, but up to 500 meter, the production of gas and oil is happening. Now see how these rigs are being moving. Now if we see the lawn again, this is the rig. It is being dismantled. If you see, first it is dismantled all in 3 or 4 parts, and then again it is being transported to the new location where it is being erected. So this is the way. Once it is being dismantled, again it has to be assembled back, and then this is to be erected. So now again the load variation. If you see that when it is in a lying position, now it is to be lifted up. So the load which is going to come on the foundations which you are making will be axial load. Load will not be uniform, only not vertical load, but there will be an axial load also, and that also to be considered, because otherwise sometimes you have seen that when we are lifting this, the foundation breaks. So those kind of things are factors also to be considered when we are designing those foundations. So now you can understand, friends, for civil engineers, what kind of challenges are there in oil and gas. If you see in offshore, offshore is pretty simple, because if you see now the legs are completely out. It's about 350 feet of legs are available. And this is a barge. This boat is towing it, these two. There are 2 boats on the back side just to support, but this is the boat which is pulling this complete barge. So there's a rig available, the mast is available, and this mast is there, and the legs are there. These legs are penetrated down below the ocean floor, and then this is jacked up. And if you see the floating rig, they are mostly self-propelled, and they just move by their own power. So this is, and if you see these, if I talk about the size of these rigs, it's about 3 to 400 meter long and about 65 to 75 meter in width. So it's a big and the structure which is floating on the ocean floor, in the ocean. So this is how offshore and onshore the drilling operation is being done. Sorry. So this is onshore how movement is being done, and offshore how the movement is being done. Now the drilling operations. Now if you see the drilling operation, it is a very I can say simple operation, but at the same time complex also, because you have to go down about 5,000 meter or 4,000 meter or 2,000 meters. So the wells which are being drilled, once the rig is at location, the first thing which we call is spudding of the well. Once if I explain here in this figure, this is a drilling bit which cuts the formation, because it has got 3 rollers here, you see here, and when it rotates, it cuts the formation. And if you see here, I'm showing this here, there's a nozzle here. So the mud is being pumped, and this nozzle from here, the mud comes out, cleans the teeth also, and it cools this area also, and then lift the cuttings also. If I show here in this figure, what is coming, going up, it is lifting the cutting also. It is a different figure, but this is how things are being done. How the drilling is done, I'll just explain that. आपने शायद पानी का बोर होते हुए देखा होगा, similar technology है. We pump mud in it. If you see here, this complete structure, the mud pumps are there. The mud is being pumped, goes up, and from here, there's a swivel here which rotates. The mud goes down. These are the blow preventers which are installed. Go down, and then it comes up. So, and it brings all the cuttings which are generated by the bits when you are rotating it. So this is how this well is being drilled, how the earth which is being cut is being removed. So this is a continuous process. This mud will be continuously circulated down below. It goes up, and then is being cleaned here again, and again the mud goes into the pits. Same mud is being circulated. Only thing, once this comes up, it is to be cleaned. Clean means the sheaves are there, normally called as a shale shaker. It removes all the cuttings, and then if sands are there, we have desanders, which removes the sands also. So these equipments which are here, they are also pretty heavy. So again, the foundation design of these equipments, design of the tanks, plays a big role in it, because we have an agitator in it which rotates all the time, because otherwise what will happen, these mud will get settled because it's very heavy. So once, and this is the how the operations are being given here in 1, 2, 3, 4. Rig is location, spudding the well. I told you that how the spudding is being done. Once the hole is drilled, then the casing is lowered. Casing is nothing, it is a basically a pipe. Initially, it is a bigger pipe, then the smaller pipe, bigger, and the smaller pipe. But it is like that. So once you drill a hole, the standard size, if I talk about in oil industry, what we do is initially we drill a 26-inch hole, and in 26-inch hole, 20-inch casing, 20-inch pipe is being lowered. Again, the design of this pipe plays a very, very important role, because the kind of formation which is coming up and the kind of pressure it has to hold. So the design of pipes will be different. If the pipe which is lowered, if you see here, bottommost pipe will have a different design, the topmost pipe will have a different design, have different capacities. So the 26-inch hole is drilled, and then 20-inch casing is lowered in that. Once any of the casing pipe, this is a casing pipe. If you see here, this is a casing pipe. They are joined together, and it goes down. Then the cementation is done. If you see here, the black color thing is a cement basically, and this cement is done because to keep the pipe in place. Otherwise, there will be no isolation between the formations. So that is to isolate. See, this is another one formation, another formation is another formation. So to isolate these formations and to provide stability to this pipe, cementation operation is being done. A similar thing is done all the time. So this pipe is lowered, then the 7.5-inch hole is drilled, then 13-thread casing is lowered, and 12 inches hole is drilled, then like that. As you go deep, the size of the hole becomes smaller and smaller. It becomes as small as 6 inches, and we lower about 4.5-inch pipe there. So once we go deep, the size of the hole which we are drilling goes smaller and smaller. So this is how the drilling is being done. Now another thing is how we are testing. Once the drilling is done, everything is there. Now we have to test the well. How the well is being tested. So for testing, again you have to blow the well. So in the testing, once the drilling is done, all the casings are being lowered. Once the casing is being lowered, and then normally we do a logging operation. So logging operation tells us that these are the formations where we can have some fluid, oil and gas, and this oil and gas is to be explored how much we can produce from this particular formation. So what we do is, for testing, first we have to perforate that formation. Once this is being perforated, then it will flow, and when it's flowing up to the surface, then it goes to different separators. So these are the modular facilities which are being created. So again, the design of these modular facilities, we have to see how to, because it has to handle multi-phase fluid. It can be water, it can be oil, it can be gas, and so many things are coming. How this separators are to handle this. So they should be designed in such a way that they can handle this under pressure, because the wells which are producing can have pressure up to 15,000 psi. So we are getting the wells from 500 psi to 15,000 psi wells. So design of these equipments should be as per the requirement of the well. So once this oil and gas which comes to the surface is being separated here and tested. So once we establish the test that yes, this kind of production this well can give, again the reservoir study is being done, and that reservoir study tells us that how big this reservoir is and how long we can produce from this well. Now the production again, sometimes people say ये तो well है इसको खोल देते हैं सीधा आ जाएगा, खोलने से पूरा तेल निकल जाएगा. ऐसा नहीं होता है, because all the reservoir have some characteristics. Once you are taking out fluid from the formations, then these formations are to be top up with the water. So water injection is to be done in that formation. It is not like that you extract oil or gas and just keep on extracting and things will come. No, it will not come by your own. Again, needs some energy. So to create that energy in the formation, the water is being pumped. So normally you might have heard about EOR and IOR technologies. So it is only water is pumped, and it is a IOR technology, enhanced oil recovery technique. And if you go for other things other than water, is enhanced oil recovery system. Sometimes you have to pump gas. Sometimes you have to gas and oil. Water is also pumped. Sometimes we do blasting down below just to make the oil movable in the formation. So these are different technologies available by which we can produce oil and gas from the formation. But once we establish that this reservoir is economically viable to produce, we will have production well there. And then these all structures, everything will be out from this place. And if you see the producing well, it will be very, very simple. So these are the facilities. If you see here, these are the wells. These are two wells I have shown on the right side of the slide. Once the well is, formation fluid is coming with the pressure, then this viscosity is installed, because it is nothing but is a combination of different valves which is installed. Normally it is called as a viscosity. Other one, if you see the sucker rod pumps, where the pressure is less. So again, like when we, you might have seen the hand pumps, we just handle is being pushed, the water comes up. So similar technology is there, that this we call it SRP, sucker rod pump normally it is. So this sucker rod pump, if you see here, it has, it's just like a pump. If you see, it is moving up and down, and it takes the oil out from the well. So this is installed only where the pressures are low and the wells are not flowing by its own. And these are installed when the wells are flowing by its own. So once these things are installed, oil and gas, which is coming out from these wells, goes to the processing facility. This is a processing facility, if you see here. This facility is there. And in this facility, you will have a separator and high pressure separators, low pressure separators, because all the wells will not have the same pressure. So according to the design, according to the wells, different manifolds are being made, and on those manifolds, these wells are being connected. If it is low pressure, it's connected to the low pressure manifold, and if it is high pressure well, then it is connected to the high pressure. Again, if you see this complete design, plays a very important role because a lot of equipments are to be installed here, and gas and oil, which is still going to come under pressure. And with this pressure, it has to. So we have to see inside design of the structure in such a way that it should not vibrate and it should function smoothly. So this, and there are a lot of big sheds are being made. So again, your design again plays a role here. So how we have to design so it is economically viable, cost effective, as well as nowadays a lot of materials are available with which we do this, and these structures, basically these structures are very heavy, and oil and gas flows through these structures, and this is the flare. Again, this flare is also again an important thing, which is again design on which what kind of formation it is, what kind of formation where it is being installed, what kind of foundations are needed for that, and what kind of tie rod or something is required to tie back. Otherwise, once the gas is going to this, a lot of vibration will take place and that should not take. So these kind of things are to be considered when we are designing this facility. So a lot of civil works you see required, a lot of equipment designs required, a lot of structuring is being done here, and again you have to see the place which is available. So that how we can how best utilize that place, how compact this unit can be made. So these are the part which the civil engineer, mechanical engineer together they have to see this, how this can be done safely, because each and every event are to be approachable. Because if something happens, the person should be able to go there and prepare or take action, corrective actions. These kind of things. These are the facilities which are there check installation. Wherever oil and gas is used, these facilities are needed. But nowadays there are few small operators which they can't afford to install these facilities. But they are doing, they are using oil and they're oil India or ONGC, some of the operators. So it is like that. So these are the structures which are needed in island. Now the production facilities in offshore. You see the offshore on my right side is a big platform which is there, which is a process platform actually. And these process platforms are installed only in a shallower depth, less than 100 meters, less than 300 feet. In more than 300 feet, this is not possible to install these kind of facilities, which you can see here. Mumbai High, most of the facilities are available in 50 to 60 meters of water depth. But if the water depth is more, then this kind of facilities cannot be set up there. We have a different facilities. You see in these facilities, process platform there, process facilities are there, and you have a lot of equipments available. Barge is there. This is the barge which has come. And this is a facility available. We have the accommodation here. We have a helideck here. So helicopter can come and run out. But these are the test for the testing. Flare stack is there. The testing, some technical gases are to be flared. These are the all again the design in the offshore is again a very, very complex thing. But you see the forces which are coming on because of heaving and underwater currents, forces which are going to come on the structures. Those are very, very important because first thing, it is about 40-50 meters in the water, erosion, protection from that is required. Underwater currents will be there, that forces, and those areas we studied for the cyclone, what kind of cyclones are there and what are the severity of the cyclone. These all structures should be able to withstand those forces when they are being there, cyclone, underwater currents, or so these structures are designed in such a way that they stand there for a longer time, that the protections are there, quite corrosion. Now, if you see in my left side, the structure is shown here. This is an unmanned platform basically, and if you see from bottom, there are a lot of wells are connected here. In one platform, depending on the reservoir which is down below, below the ocean floor, whether to drill 3 wells, 4 wells, or 6 wells, or 9 wells, or 12 wells, or 16 wells. So this kind of number of wells are being drilled from these. So again, the structure design should be such that they should be able to withstand the load of those wells which are being drilled from there. And apart from that, the well, oil and gas which is being produced from this well they should be in a position, the facility should be in a position to pump that oil and gas from here to, from this platform to the processing platform. These are the individual platforms. If you see in Mumbai High, you will be seeing about 140 platforms are available there, where the wells have been drilled. From few wells, few of the platforms, we have drilled even 12 wells, 16. Can say 16 wells, but we can add on also. So again, if you want to add 2 more or 6 more, so that add-on facility is also there, that can be done in this. So again, the structure design should be such that yes, future if something is to be done on that, should be capable of doing. So these are the again design marvel. If you can understand things here, kind of forces the structures will be totally different. And again, you have to see that from here, what this oil and gas which is being produced goes to the ocean floor and then comes to this process facilities. Again, the laying of those lines and all. Again, it's construction work, I can say. So again, the design is required. The kind of pipes which you are going to use and the kind of forces will be there on those pipes will be different because it will be always under pressure, and they should be in a position. The one should be pipe should be laid in such a way that they should, in case any leak develops, that they should be able to repair pipes. So this is how the production facilities are developed in offshore. Another consideration, if you see, one is the corrosion, another is weight. Because nowadays, previously, if you see, all steel structures were there, which were installed. But nowadays, aluminum alloy steels is available. Aluminum structures are available, which are capable of taking the loads as in case of we have seen in steel. So if you see here, these helidecks, mostly in ONGC, we have changed all the helidecks to the aluminum structure, where the weight is reduced by almost 70%. So with only 30% of weight, so now your variable load has increased. You can add some more facilities here by reduction of the weight. So again, the platform has become more safe. So another consideration when we are doing it, the 2 main considerations are corrosion and weight. Another is forces which are to come during the cyclone or during the rough weather conditions or underwater. These are the things which are to be seen. So another facility, if you see here, when you are going in a deeper production, in a deeper horizon where the water depth is more than 100 meters, 300 feet, so then the facilities required are different. if you see here, the total facilities are installed at the ocean floor. These are the facilities installed at 2,500 meters. You see here, these are on each and every well, these structures are lowered. These are subsea trees, we call it basically. You see on top, there was a Christmas tree, but here it is a subsea tree. These are the subsea tree. Basically, again, it is a combination of valves, but these valves can be operated by remote operated vehicle, ROV. If you see on the left of this figure, these are the ROVs. These ROVs are being controlled from the top, from the ship, and these ROVs can open and close the valves and can do some small repairs. Some hoses damaged, or they can repair the, change the rope, because it has got 8 motions actually. You see carefully, this has got arm. You see, this is arm, which is visible here. This arm has got 6 motions. So just like our hand. So you have to direct from the surface what is to be done. So these are the again engineering marvel. So again, a lot of designing is required, and how these are to be installed in these facilities. Manufacturers of these facilities are very few, only 3 in the world, and if you see how these wells are being produced. From this cluster of well, line is coming. This is again a flexible line. Normally, we call it as a flexible riser, and then this goes to facilities at the top. You see here, this is a floating facility, call it as FPSO, floating production storage offloading. So this has a facility to segregate oil and gas. That kind of facilities are available here. And from here, oil is being sent to the tankers and it goes to the refineries. But gas is again going through the pipeline. But in some of the facilities, not in India but outside, the gas is being liquefied. Again, the liquid gas is being offloaded and it is going to the shore. So that depends on, again, the total economic, how this oil and gas you want to produce. If you want to liquefy, again, the cost is there. So these are the things which you have to see according to the market. The facilities are being created. But nowadays, actually, you know, because of the COVID and all, gas and oil. So this kind of setting up of this kind of facilities are bit costly, because cost of production from this kind of well varies from about $60 to $70. So unless the cost of the island not $70, would be not economically viable to use. Somebody has produced in the beginning, then they get aware of. But otherwise, in India, we wanted to develop for feed. During my period, we have sanctioned for that, but still we are not in a position to do it because COVID again, and the cost production there was about $65. Today, if you see the oil price, so again the economics are to be seen, but we are engineers. By that is a different position when in the beginning we think that how we can make these things happen, how structurally we can do this. From our point of view, basic engineering point of view, these are the things which are possible and are being done. And now only thing we have to see how economically these activities can be performed by use of new technology. So that is the challenge which I think we have to see how the IoTs business which is available. So this is how the production is being. But now I'm coming to another slide, is challenges in oil and gas. What are the different challenges? The first challenge I was just talking about, volatility of oil and gas prices. So now if you see, sorry, production of cost of gas from ONGC, I talk about Oil India, I talk about, it's about $2.5 per MMBtu. But today is the price which has been by the government is about $1.79. Now you understand, you are producing at 2.5 and selling at 2.79. Basically, ONGC is a PSU, so produce. Oil India is a, but other companies, they will not produce that gas. They take losses because we are PSUs. So we are producing. But again, good news is now Parliament has passed another notification has come that now you can go for a market price. You discover your own price and go it. So now I think the activities will increase and we'll be able to produce more gas. And if I talk about oil and gas, I'll just give a little overview to you people that India produces only 14% of its requirement in case of oil. But in case of gas, we produce about 50% of our requirement. Now you see, we are importing about 86% of oil and about 50% of gas used in India. So this kind of thing. So there's a lot of potential in oil and gas. A lot of fields are available. That's why India, the government is coming with the new plans that yes, more and more people come and participate and do these activities of drilling oil and gas, uh, producing oil and gas in the country. But now you can understand the challenges and what are the things. But other challenges which are there in the infrastructure is laying pipelines and maintenance of those pipelines. Our places, if you see, some places we have the population and even the population is there, not there, pipe is passing through the fields, people will not allow right to use, no, if you use it. The reason is once you lay the pipeline, these pipelines are laid about 6 meters below, say 6 feet below the ground. They can do farming on that, but you can't do any construction. So sometimes people are afraid, they don't want to give part away with these lands because they said if you take line, price of our land comes down because nobody can make a permanent structure on top of that. So these kind of things are the challenges are there, but still, with the help of the government and all, these challenges are being overcome. But the engineers who are working in the field will start having definitely a tough time when we are laying these lines in the field. Because I understand my son is an engineer. He used to discuss with me, sir, Papa, what difficult काम है. This is how. And maintenance of these lines are also another thing because you might have seen a lot of people do a lot of theft from these lines because when you're producing flowing diesel, petrol, oil from these lines, people get to attempt to tap and take out the oil and gas for their use. That is happening. That is another threat which is there. Maintaining these lines, another challenge. One big challenge is Indian fields are about where we are producing at present are about 40 to 60-year old. There is no field, and the facilities which are available are also very old. So doing any job in these kind of structures which are very old is a challenge. Challenge is you can't stop the production and at the same time you have to do modifications also. So there's a big challenge for the engineers. How to balance between these two is another challenge which we have to see that. But things are happening. Uh, but definitely some losses will be there because you can't make 100% production and 100% renewal of the facilities. That cannot go hand in hand. But definitely by good design, we can see that how can we can minimize the losses, means loss of production, and how fast we can construct those new facilities which are needed or which is a need of the hour. keeping the safety standard in. Another is technology induction. In the PSUs and all these places, technology inductions, people think, oh, nomination mein de denge. But I'm not going to those parts. I'm not, because this is not a part of the. Only thing here, you have to make your students so bold that they.
महावर साहब आवाज नहीं आ रही आपकी.
मेरी आवाज नहीं आ रही?
आ रही है सर, आ रही है.
आवाज आ रही है?
Yes.
मैंने कुछ डिस्टर्ब नहीं किया, लेकिन आई थिंक.
Sir, please continue, sir.
ऑडिबल है?
आ रही है.
वो शायद आपका कहीं है, वो तार निकल गया होगा, देख लीजिए. कभी कभी आता है, टेक्निकल ग्लिच होती रहती है. So technology induction is one thing which is very, very important. And if you see in the government structure, we go by tender. And I used to say all the time, you can't buy any new technology with a tender. It is not possible. We have to inculcate some of the value system in our students, that yes, they should be in a position to take bold decisions. Otherwise, if you want that this country has to progress and they have to move further, we have to become self-reliant. That kind of thing is required. One has to make decisions, and you should see that yes, it is technology which is going to give us definitely more production of oil and gas and good structures which can efficiently produce more oil and gas. So these are the things which you have to inculcate. Another thing is pollution and environment damage. This is very, very relevant in nowadays, because if you have seen the environment damage, because the oil and gas which are coming, there's a lot of dirt in it, and sometimes we have to burn. So these are nowadays, emphasis has been given that we should not burn any gas. So whatever the gas, even a technical gas which is going to the, which is needed to be flagged, how we can gainfully utilize that to convert into an energy form. So these are the challenges which we have to see, how we can make sure that industry is not polluting and at the same time the environment is safe. So this balance is to be made. And another thing which is there is difficult terrain in onshore. If you see some of the places, it is good if you go to the western sector, things are very good. When you go to the eastern sector, I was in Agartala. If you see any of the road, you will not find a single patch of 100 meters straight road. So it is so much hilly terrain, and the hills are just like the sand, which is very, very different type of thing. If you see in dry season, if you are cutting those small hillocks, it will just like that you are cutting a rock. But in one rain, you will just find that they are just like a marshy land type. Just जैसा दलदल हो जाती है ना, उसी तरह से. So that kind of soil which is there, and you have to work in, let's say, 365 days in a year. So you have to design the infrastructures in such a way that even if it is dry season or the rainy season, we should be in a position to work in that place. Because we were finding it very challenging many times that the rain comes, people are not able to approach those places. So we have no doubt our civil engineers and mechanical engineers has come out with some of the good structures and some of the new technologies by which we were able to increase the bearing area and we were able to work. Even the cranes were moved on those kind of structures. So things are happening, but these are the challenges. If you see in the this figure here, these are two hillocks which has been cut and a road has been made. And now here in this place, we will be constructing the site to bring that rig and all. See how challenging it is. And another challenge in offshore is weather. In onshore, these are the challenges, but in offshore is a different challenge. If you see in offshore, if you go to the eastern sector, the sea bottom is such that if you penetrate, sorry, about 15 to 20 meters, just go down any of the pipe you lower, it just go down by its own weight. So the soil is so loose there. So in that area, you have to drill a well and so much load has to come on top of it, about approximately 700 tons. So what is to be done? How to increase the bearing area? So again, there's challenges there. So you make some structures. We used to make the float boxes, big boxes, lower it. So that is increasing the bearing area and all like that. So this kind of design is. But when you go to Andaman, I was there in Andaman for 3 years. See the bottoms, the bottom is just like rock. So the cutting those rocks and making the things straight in those rocks, again a challenge. So things are different. But when you come to Mumbai High, western sector of the country, the land is very good. If you see the sea bottom is very good, plain, and you will be able to work without any problems. So these are the different places, different challenges are there. If you go to the Park Street, the bottom somewhere, the Rameshwaram and all these places are there. There again the challenge is the rocky bottoms, but very steep, just like hills below the sea. So again, those places you are drilling, infrastructures which you are going to make or the rigs which you are going to take there will be taken care that yes, in this area it will be able to work. So the big challenge in offshore is weather. Sometimes you may have to work in the cyclonic period because I was there in one of the cyclone. Basically, these rigs are kept stable by anchors, and we have about 8 anchors installed in this, and 5 of them have broken. We were there on only 3 anchors, but those 3 anchors have kept that vessel in place, but it was drifted about 100 meters. So these kind of challenges are there. So now the design of these has been changed. Now we are not going for anchor system. We are going for dynamically positioned vehicles. So the DP vessels we call it. So once dynamically positioned there, it has a lot of thrusters, about 16 to 20 thrusters. So immediately if this kind of situation comes, it can move from that location immediately. So that breaking of anchor things are. So like this designs are, things are improving day by day, and the new technologies are coming, and with this we are in a position to work in the harsh environment condition and in offshore also. So friends, with this I just end my presentation, and I tried that to give an overview what kind of things are there and how this oil and gas things are working, but it's not very, I can't summarize everything in 1.5 hours, but about an hour I could able to give a overview that in oil and gas, what kind of infrastructures are there. Let me come back to